A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello. So, we are studying about the factors that are affecting equilibrium of a system. And another factor that affects the equilibrium of a system is pressure. We know that pressure has a significant influence in the case of gases only. And also, pressure has effect on equilibrium of a system only if the total volume of reactants is not equal to the total volume of products. Now, let us examine the influence of pressure in the manufacture of ammonia. Look at this equation. N2 plus 3H2 reversibly gives 2NH3. In this equation, what is the total number of moles of the reactant molecules? 4. That is total volume 4, right? What about the products? 2. That is total volume 2. We know that here both the reactants and the products are gases. Here in the forward reaction, 4 molecules of reactant molecules get converted into 2 moles of product molecules, and as a result of this, volume increased. We know that in a system, decreasing number of moles helps to decrease the pressure. So, according to Le-Chatelier principle, when pressure of a system at equilibrium is increased, the system will try to attain equilibrium by reducing pressure. In the manufacture of ammonia, the reaction in which direction result in the decrease in the number of molecules? Forward reaction, right? So, if we increase the pressure of the system, the rate of reaction in the direction where volume gets decreased will increases. So, in the case of manufacture of ammonia, as the pressure increases, the forward reaction increases. That is, more quantity of ammonia will be formed. Now, what will happen if the pressure of the system at equilibrium is decreased? If we decrease the pressure of the system at equilibrium, the rate of reaction in the direction where volume gets increased will increases. In the case of ammonia, as the pressure decreases, the rate of backward reaction increases. That is, ammonia gets converted into nitrogen and hydrogen. What may be the reason for maintaining a high pressure of 150 to 300 atm during the manufacture of ammonia? We have learned that the rate of forward reaction increases as the pressure increases. So, high pressure is used in order to increase the production of ammonia. Now, look at this chemical reaction. H2 plus I2 reversibly gives 2Hi. In this reaction, what is the total number of moles of the reactant molecules? 2. What about the products? It is also 2. Here, there is no change in the number of moles of the reactants and products. Such reactions in which there is no change in the number of gaseous molecules in the reactants and product side, pressure will not have any effect on the chemical equilibrium. Now, let us discuss the effect of temperature on equilibrium of a system. We have learned that an energy change is associated with a chemical reaction, and we also learn about endothermic and exothermic reactions. In a reversible reaction, if the forward reaction is endothermic reaction, then the backward reaction will be exothermic, and if the forward reaction is exothermic, then the backward reaction will be endothermic. Look at this equation. N2 plus 3H2 reversibly gives 2NH3 plus heat. Which is the endothermic reaction here? Backward reaction, right? Here, what will happen if we reduce the temperature? The system will try to increase the temperature, and as a result of that, exothermic reaction will be increased. Here, the forward reaction, that is the reaction in which nitrogen and hydrogen get converted into ammonia will be increased. What will happen if we increase the temperature? The system will try to decrease the temperature, and as a result of that, endothermic reaction will be increased. That is, ammonia gets converted into nitrogen and hydrogen. So, according to Le-Chatelier principle, in order to get more amount of ammonia, the temperature should be reduced. In the manufacture of ammonia, 450 degrees Celsius is taken as the optimum temperature. That is, at optimum temperature, the number of molecules that attain threshold energy will be maximum. What is threshold energy? It is the minimum amount of energy required by the reacting molecules for a reaction to take place. Hope you have understood the effect of temperature on equilibrium of a system, right? Now, let us discuss the effect of catalyst on equilibrium of a system. We know that catalysts are the substance which can change rate of a reaction. The catalyst which can increase the rate of a reaction is known as positive catalyst, and the catalyst which can reduce the rate of a reaction is known as negative catalyst. In a reversible reaction, there are forward and backward reactions. Catalyst cannot increase the rate of only one among these. That means a catalyst increases the rate of both forward and backward reactions to the same extent. As a result, the system reaches equilibrium at a faster rate. Is it beneficial to add catalyst in a system which has already attained equilibrium? No. That means catalysts are used in order to attain equilibrium at a faster rate. I hope you have understood the various factors that affect equilibrium of a system. See you later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.